So these are notes 2.6, which are on multiplying and dividing rational expressions. Before we get into it, I just want to do a quick review with you guys about how to multiply and divide regular numbers, and then we'll see how we can apply this to our rational expressions. So if you take a look right here, we have 3 over 5 times 10 over 6. And remember, if we have numbers in common in our numerators and our denominators, then we can cross-reduce. So what we're going to do here is we are going to cross-simplify or cross-reduce. Okay? So if you notice right here, we have a 3 here and then we have a 6 here. Both are divisible by 3. So when I divide 3 by 3, I get a 1. When I divide 6 by 3, I get a 2. Okay, I can also look at the 5 and the 10, and same thing when I divide 5 by 5 and 10 are both divisible by 5, so when I divide 5 by 5 I get 1, when I divide 10 by 5 I get 2. So now I'm left over with a 1, a 2 in my numerator, and then another 1 and another 2 in my denominator. But looking at my numerator and my denominator here, they also have numbers in common. They're both divisible by 2. So this 2 can become a 1, and this 2 can also become a 1. So now all I have left to multiply together is this 1 times this 1, which gives me 1. And then in the denominator, I have 1 times 1, which is also 1, so I get 1. Okay, that's one way I could do it. Another way I can do it is to just simply multiply across and then reduce. So if I were to do that, then I would end up getting 3 times 10, which is 30, over 5 times 6, which is also 30, so then I end up getting 1. Okay, now depending on the problem, sometimes it'll be easier to cross-reduce first, sometimes it'll be easier to just multiply across. Okay, so if you take a look right here, we have 4 over 9 times 39 over 52. So the first thing I'm going to do is I'm going to notice right here that I've got 39 and 52, and both of those numbers are divisible by 13. And when I divide 39 by 13, I get a 3, and when I divide 52 by 13, I get a 4. So it's almost like I've got a new fraction of 3 over 4. Okay, now that I've done that, I can also see I've got a 4 here and a 4 here. Both 4s are divisible by 4, so this 4 becomes a 1 and this 4 also becomes a 1. I also have a 9 and a 3, which means they're both divisible by 3. So 9 divided by 3 is 3, 3 divided by 1 is 3. So now, looking at my new numerators and denominators, I don't have anything left in common, so I'm just going to multiply across. So my numerators I'm going to multiply together are going to be 1 times 1, which is 1. And then I can also multiply 3 by 1, which is 3, so I get 1/3. That's one option. The other option is to multiply straight across and then simplify. Now 4 times 39 and 9 times 52 give me numbers that I'm not as familiar with their factors, so it might be easier to just simplify to begin with. Okay, all right, and then the last example here we have is 3 over 2 divided by 9 over 4. But before we do that, I just want to talk really quickly. Like, for example, if I gave you 5 items and I told you to divide them in half, that means that I would end up getting 10 pieces. So if you count these all together, you end up getting 10. So essentially what I'm really doing is I'm taking 5 pieces and I'm doubling how many I now have. They're smaller, but I'm still doubling it. So I'm multiplying by 2. So if you remember, we're going to keep the 5. We're going to change the divide sign to multiplication, and then we're going to do the reciprocal of 1/2, so that's how we end up getting 2, and 5 times 2 is 10. Okay, so over here, what I'm going to do is I'm going to keep the 3 over 2, change the division sign to multiplication, and then flip the 9 over 4 to the reciprocal of 9 over 4 and make it 4 over 9. Now I can go ahead and do some simplifying. So the 2 and the 4 are both divisible by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Okay, then I also have 3 and 9, which are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So I end up getting 2/3 as my final answer, because 1 times 2 is 2, and 1 times 3 is 3. Okay? Okay, so now let's apply this to rational expressions with variables. So step 1 when we're multiplying rational expressions is going to be to factor if possible. Okay, then we're going to cancel values or cancel terms or expressions. And you can only cancel if one is in the numerator and one is in the denominator. So for example, here, if we look up here, we could only cancel the 4 with the 4 because one was in the numerator and one was in the denominator. But if I had like 3 over 2 times 5 over 10, I can't cross this 2 out and cross this 10 out and go from there because they're both in the denominator. Okay, so let's just cross this piece off. We don't need this piece right here. And then let's add a step 3, and that's to multiply, then simplify. Okay. All right, and then for dividing rational expressions, what we're going to do is we are going to, just like we did up here, we're going to keep the first term right here. Then we're going to change the second term to multiplication, and then we're going to do the reciprocal of the last term, so we're going to flip the last term. Okay, so keep, change, flip, and then follow the same steps for multiplication because we changed this multiplication sign to this division sign to multiplication. Another way to say it, and actually this is probably preferable, we're going to just multiply by the reciprocal, okay, and this is preferable because it's more mathematical, okay? We're just going to multiply the first fraction by the reciprocal. So let's go ahead and look at number 1. We've got 2 different options. My first option is to cancel exactly how I see it right here. So for example, I see this 5 and this 20. Both numbers are divisible by 5. 5 divided by 5 is 1. 20 divided by 5 is 4. So I can put a 1 and a 4 there. Okay. I also see this 3 and this 9. The 3 is divisible by 3 and I get 1. 9 is divisible by 3 and I get 3. Okay. Then what I'm going to do so I don't get confused is I'm going to rewrite what I have here. So I just have a 1 here, so I don't really have to write that down. And I have an x squared left over in my new fraction. Okay? And my new fraction down here, I have another 1, but I don't have to write it down, so I'm going to write xy. Okay? And then in my second fraction, my new numerator is going to say 3. And then I'll have y squared, and then my denominator is just going to be a 4. Now I'm going to go ahead and do some more canceling. So if I look at this right here, I can see that I have an x squared on top and an x in the denominator. So one of these x's is going to cancel out with this x, and those 2 are gone, so I have an x left over in the numerator. I also have a y in the denominator here and a y squared up here, so this y will cancel out with one of these y's up here. So what's left over up here, I'm going to highlight it, is I've got an x, I've got a 3y, okay, and then I've got a 4. So that means that when I multiply it all together, my final answer up here is going to be x times 3y, or 3xy, all over 4. Now you may not like that because it just kind of gets confusing with all of this stuff, all of this canceling out. So instead what we could do is we could just multiply across and then simplify afterwards. So if I've got 5x squared times 9y squared, 5 times 9 is 45, and then x squared times y squared is x squared y squared. Okay, and then in the denominator I've got 3 times 20, so I get 60 xy. So then looking at my numerator and my denominator, I'm going to find a GCF. So what's in common with 45 and 60? They're both divisible by 15. And then x squared, y squared, and xy both have an xy in them. So I'm going to factor those out. When I factor out 15 from 45, I get 3. When I factor out x from x squared, I get x. Then when I factor out a y from y squared, I get y. And then in my denominator, when I factor out 15 from 60, I get 4. And then the xy from the xy, there's nothing left over. So then I can say these guys cancel each other out. So my answer is going to be 3xy over 4, and I'm good to go for that question. Now you've got a lot of different options. You can either simplify first and then multiply across, or you can multiply across and then simplify second. Now notice how we said that you have to factor first. When you have a bunch of monomials, you don't have to factor, but once we get to a point where we have other things that are not monomials, you'll definitely have to see if you can factor. Okay, so now take a look at example number 2. It says 10ab over 14a squared divided by 25b cubed over 7ab squared. So the first thing I'm going to do is I'm going to rewrite it with my multiplication by the reciprocal. So I'm going to copy down the 10ab over 14a squared, okay? And then I'm going to, instead of divide right here, I'm going to multiply. And then instead of having this fraction right here, I'm going to have the reciprocal. So I'll have 7ab squared over 25b cubed. Okay, so now that I've done that, the next thing I'm going to do is I'm going to start canceling stuff out. So for example, this 10 right here and this 25 are both divisible by 5. The 10 becomes a 2 when I divide it by 5. The 25 becomes a 5. Okay, 14 and 7 are both divisible by 7. 7 divided by 7 gives me 1. 14 divided by 7 gives me 2. I also have a 2 in the numerator and a 2 in the denominator. 2 divided by 2 is 1. 2 divided by 2 here is also 1. So those cancel out as well. Okay. I have an a with an a squared. So one of these a's is going to cancel out with one of these a's. And I still have an a to the power of 1 left over. Now here I also have 1a here and 1a here are going to cancel each other out, okay? And then here in my new fraction up here I've got b squared over b cubed. 2 of these b's cancel out with 2 of these b's and I have a b left over, but this b cancels out with this b up here, so those b's are gone as well. Now be really careful because you will have a lot of stuff crossed off and a lot of stuff left over, and you have to be really careful about making sure not to lose anything. So when I look right here, I can see, well, I have a 1 here and a 1 here, and everything else is canceled out. So that means that I have a 1 left over in my numerator, okay? I also have a 1 left over in my denominator and a 5, and everything else is canceled out. So 1 times 5 is 5. So 1/5 is my final answer. Now remember, you could also, if you prefer, multiply across and then simplify afterwards. Right, in number 3, we have a fraction multiplied by another fraction. So here I don't have to do any kind of multiplying by the reciprocal, any flipping, none of that stuff. So I can go straight to factoring because I have more than just monomials, only more than just one term in each one of my fractions. So let's go ahead and factor the first numerator. So if I look at this numerator up here, the first question I always ask myself whenever I factor is there a GCF? And looking at 21 and 3, there's a GCF of 3. And looking at my x and my x squared, remember we always look for the lowest exponent, so it's going to be x to the power of 1. Okay? When I factor out a 3x from 21x, I get 7. And when I factor out a 3x from negative 3x squared, I get negative x. Okay? And then in my denominator here, it says 4x squared plus 16x. Sorry, before we move on, I'm done with this because inside of my brackets I can't factor this any further because it's a binomial, but it's not a difference of perfect squares and there's no more GCF. Okay, so looking at my denominator here, the first question I ask myself is there GCF? And there is. My GCF would be 4 because 4 and 16 are both divisible by 4, but I also have an x in common, so it would be 4x. And when I factor out a 4x from 4x squared, I get an x. And when I factor out a 4x from 16x, I get a plus 4. Okay, and this is not factorable any further. Okay. So now, in my second fraction, in the numerator right here, I'm going to ask myself, is there a GCF? No, there's no GCF. Is it a difference of perfect squares? Nope, because it's a trinomial. Since it's a trinomial, I'm going to try to see if I can factor it using guess and check. So I want this to multiply by this and get 12. And I want my last terms to multiply together to get x squared. Okay, so what times itself what multiplied by what would give me 12? Well, I could try 3 and 4, okay? And then what times what could give me this x squared right here? Well, I'd try x and x. And if I look at this right here, my inside gives me 4x, my outside gives me 3x, which is exactly what I want because they would add up to the 7x I'm looking for, okay? So then I want it to be a positive 7x, so I'll put a plus sign in between both of these guys here. And then each one of these terms here is not factorable any further, so I'm done with my numerator. Now in my denominator here, same thing. I'm going to look for factors of 14. I'll try 7 and 2. And then I'm going to also look for factors of x squared. So I'll try x and x. And then I'm going to figure out what my signs are going to be, figure out if these numbers work, and then figure out my signs. So I've got 2x and 7x, and I can get negative 9x if they're both negative. So now that I've done all of my factoring, and only because I'm done with all of my factoring, I can go ahead and do some canceling, okay? So if you guys notice right here, the 7 minus x is like the 7 minus x. I can cancel it out, okay? X plus 4 here is just like 4 plus x here. The order doesn't matter when you're adding, so I'm allowed to cancel those guys out, okay? This x will cancel out with this x right here. So looking at whatever I have left over, there's nothing left that I can multiply together or cancel out. So I'm going to multiply together what's left over. So if I look here, these are my terms that are left over. So when I multiply them together in my numerator, I'm going to end up getting 3 times 3 plus x. And in my denominator, I'll end up getting 4 times 2 minus x. And this right here would be my final answer. Okay? All right, let's take a look at number 4. This time I have division, so I'm going to multiply by the reciprocal. So I'm going to copy down 32x to the power of 5 minus 200xy squared over 4x plus 8 because my first fraction stays the same. Then I'm going to change the division sign to multiplication, and then I'm going to multiply by the reciprocal. So this 3x squared plus 11x plus 10 that I used to have in my denominator is now in the numerator, and then the 10x cubed y minus 4x to the power of 5 is now in my denominator. Okay? What I'm going to do is try to factor out the GCFs in any of my expressions that I have in my numerators and denominators, and then I'll go from there. So looking at my first numerator right here, there appears to be a number that 32 and 200 are both divisible by. They're divisible by 2, they're divisible by 4, but the largest number they're divisible by is 8. So I'm going to factor out an 8. But I also have x's in common. There's an x here and an x here. So I'm going to factor out an 8x. Well, when I factor that out, I end up getting 4, because 32 divided by 8 is 4, x to the power of 4, okay? And then when I factor out the 8 from 200 right here, I end up getting minus 25. The x's will cancel each other out, so I end up getting just 25y squared. And then in my denominator, I have a GCF of 4. So when I factor out the 4, I get x plus 2 inside of my brackets. Okay. Now in my next set right here, in the numerator up here, there is no GCF because there's nothing in common with 3, 11, and 10, and there's no variable in common with all 3 of my terms. So I'm going to copy it down as 3x squared plus 11x plus 10. Okay, and then in my denominator, I'm going to look and see, well, they both are divisible by 2, so my GCF for my coefficients is going to be 2. But there's also x's in common, and I look for the lowest exponent between a 3 and a 5, so it would be x to the power of 3. Okay, so then when I factor that out, 10 divided by 2 is 5. The x cubes cancel, so I get 5y. And then here, 4 divided by 2 is 2. X to the power of 5 over x to the power of 3 is x to the power of 2. Okay, now that I'm done with that, I'm going to see if I have any differences of perfect squares. So this 8x, there's nothing I can do with it, so I'm just going to copy it down. Now looking at what I have in my brackets here, I have a binomial, I have subtraction, and I have 2 perfect squares. So this is a difference of perfect squares. So 4x to the power of 4 will break down into 2 sets of 2x squared, because when I multiply them together, I get 4x to the power of 4. And then this 25y squared will break down to 5y and 5y, because 5 times 5 is 25, and y times y is y squared. Then I'll have a plus and a minus sign, because remember, that cancels out my outer and my inner terms. Looking at what I have here, I can't really factor my first term any further. I can't factor my second term any further, and I can't factor my third term any further. So I factored completely. I'm going to copy down the 4 times x plus 2 because this is also factored completely. Okay, now in my numerator up here, there is no difference of perfect squares because it's a trinomial, but because it's a trinomial, I'm going to try to factor it by trial and error, okay, or decomposition if that's what you prefer. So when I multiply my first by my first, I should get 3x squared, so I'm going to try 3x and x. And when I multiply my lasts together here, I should get 10. So I'm going to try to put a 2 here and a 5 here because I know 2 times 5 is 10. And I want my outside and my inside to add up to give me 11x. So this gives me 2x, this gives me 15x. There's no way that I'll get the 11x that I want. So that doesn't work. So what I'm going to do is I'm going to switch my 2 and my 5 around. I'll put my 5 here and my 2 here. This gives me 5x. This here gives me 6x, so when I put the 6x and the 5x together, I can get an 11x if they're both positive, okay? And then in my denominator, I can't do anything with the 2x cubed, and then here, this is a binomial, but it's not a difference of perfect squares, so I can't factor it any further. So that's as far as I can go for each one of my expressions here with regards to factoring. So let's go ahead and start getting rid of stuff. Well, I have an 8 here and a 4 here. 8 divided by, 8 and 4 are both divisible by 4, so this becomes a 2, this becomes a 1. Okay. I also have a 2 here in the numerator and a 2 in the denominator. Those both cancel out and become 1s. Okay. X plus 2 and x plus 2 will also cancel each other out. This x cubed that I have here will cancel out with this x. One of these x's go away, so I have 2 left over in my denominator. Okay. And then I also have these two terms right here, which look almost the same, but remember they're negatives of each other. So I can cancel these out as long as I make one of my numbers up here negative. Okay, and there's nothing left for me to cancel out. So what do I have left to multiply together? I have a negative 1. I have 2x squared plus 5y. I have 3x plus 5. And then in the denominator, I have x squared. So that means that my final answer is going to be negative 2x squared plus 5y times 3x plus 5 all over x squared. And that's my final answer. This stuff can get really tricky, so if you have any questions, please write them down and let me know next time I see you guys in class. All right, see you later.